right, we've been looking at graphing radical and rational functions, and now we're going to be looking at graphing exponential functions. That is when you have an equation of the form f of x equals some number to the x power. So let's start by putting in 0. You should remember something that we really emphasized, which is anything to the 0th power is 1. You guessed it. So we always have the point 0, 1 on our graph. Now what if I had 4 to the first power? Well, 4 to the first power is 4. So I have the point 1, 4. What if I had 4 to the second power? Well, that would be 4 squared, which is 16. So you can see this graph grows very, very quickly. It's all the way up there already. So the right-hand part of this graph is done. Now, the left-hand part of this graph, let's say we're raising 4 to the negative 1 power. Well, 4 to the negative 1 power is the same as 1 over 4 to the first power, which is 1 over 4, which as a decimal is 0.25. So we have the point negative 1.25. From there, it's going to get smaller and smaller, approaching 0, but never getting there. So we've got our first exponential function. That is the general shape for a positive exponential, as we will see. It just depends on what the value is, which will change the shape of the graph. Now, let's look at the next example. So this is 3.7 to the x power. Now, it's going to look very similar to 4 to the x power. I just want you to know if you have a decimal, you treat it the exact same way you treat an integer. It's just you probably will need a calculator. So let's put in 0. 3.7 to the 0. That would be 1. So 0, 1. What about the first power? 3.7 to the first power is 3.7. This is where you're going to need to go partway between 3 and 4. 3.7 squared, that's when you'll probably need a calculator. It's hard to do 3.7 squared in your head. So you can just type in 3.7 times 3.7. Get 13.69. So we go over 2 up. It's going to be somewhere still up here. If we do negative 1, it should be 3.7 to the negative 1, which is 1 over 3.7. As a decimal, 1 over 3.7 is 0.27. So it still has a very similar shape to our first graph. It's just tiny bit different. So just know if you have a decimal, don't freak out. It's the same as an integer. You'll probably need a calculator. Let's say you have a fraction. Also, don't freak out if you have a fraction. If you put in 0, you get 1/2 to the 0 power, which is still 1. Now, what if you put in 1? 1/2 to the first power. 1/2 to the first power is just 1/2. So that means we go over 1 up, 1/2, 0.5. Now, this is different from the other ones. We're going to be going down as we get larger. What if we put in 2? 1/2 squared is 1 squared over 2 squared. We're distributing the square, which is 1/4. So we go over 2 up 1/4, which is halfway between 0 and 0.5. Let's put in negative 1. 1/2 to the negative 1 is actually 2 over 1, which is 2. So whenever we have a fraction to the negative 1 value, all we need to do is take the reciprocal. So that means negative 1, we go up 2. So this is the shape of our exponential function of a fraction. Notice it's different from the first two. The first two were increasing as x increases. This one is decreasing. As x increases, because we continue to multiply a half by a half. We're taking a half of a half of a half of a half. It's going to keep having. versus on the previous ones, we were multiplying them by larger and larger values. All right, best of luck on your workbook pages.